Now that you know a bit more about the problem we need to solve, let me explain you the concepts of MVVM, aka the view model pattern. So what is this MVVM thing all about then? Well, I'm glad you asked. The MVVM pattern, or in full, the model view model pattern, is basically an architectural pattern that is very similar to the MVC, so the model view controller pattern, which you may already know from other technologies such as ASP.NET MVC. Just like MVC, the goal of MVVM is achieving a high level of separation of concerns. Separation of concerns comes down to writing our code so that each piece of code has one specific task and nothing more. Very often, we write code where we are doing a lot of different tasks in one single place, and that is really not a good place to be in. This code becomes messy and becomes also hard to maintain. Following the separation of concerns principles basically means that we will have a class that does data access, another class contains the code for the view, and so on. So in essence, MVVM is a pattern that will help us doing this. It works because of the foundations that we're getting from the XAML language, and perhaps more importantly, from the data binding part. I've already mentioned in the previous module briefly that MVVM is relying heavily on the concept of data binding. Without it, it would be hard to reach the same effect. By using MVVM to build our applications, the codebase will become a lot more structured and the code will be more maintainable and testable. Because we will extract code in separate blocks, each with a specific goal, making changes will become easier. We will see that testing MVVM-based code is a lot simpler than testing code which is written without it, even for the view code. Let us look at a graphical representation of this. What you see here is how we would typically write a Xamarin Forms application using a regular code behind approach. Our views, so the screen, consists out of XAML code. Let's say that is the mainpage.xaml, and the code behind for this view, so that would be the mainpage.xaml.cs. All the UI code is of course placed in mainpage.xaml, but we will end up with lots of code in the code behind. The fact that it's a lot of code isn't really a big issue. What is an issue though is that there is typically code that will be doing a lot of things. It will talk to the model, so get in the data, and on the next line will be updating the UI, for example by setting the text value of an entry. That code is inherently difficult to test. It is not separating the concerns at all. And of course, once we bring in the UI related code, it is difficult to test anyway. So while this approach works, it might not be the best approach. If we now look at applying MVVM, things will change. We will still have XAML code. In fact, we might have slightly more XAML, but we'll have very little, if any, code in the code behind. If we have code in the code behind, it's going to be view-related code. So perhaps something like setting the focus on an element. What we shouldn't have in there is code that does something with the model. Next, what we are going to add is an abstraction for the view, called the view model. In essence, the view model is a model for the view. Amongst other things, it will expose data for the view to bind on. Indeed, this is where the data binding part comes in. The view code, so the XAML code, will be data binding on this new object, the view model. That will be exposing data. The view model will also be doing the communication with the model. It'll ask the model for data and get that back. Once retrieved, it'll expose that new data for the view so that it can then data bind onto it. But how does the view know about this new data then? Great question. The answer is again, well, data binding. Through the change notification system in data binding, powered by the iNotifyPropertyChanged interface, will the UI get in notifications about the changed data, and it will update accordingly. As you can see, data binding plays a very crucial and central role in the whole MVVM process. Although I hope that you already picked up a few advantages in my explanation so far, I think it's useful to look at all the benefits I see. I just mentioned that we are going to introduce the view model as an extra layer on the view. That should ring a bell. Indeed, we are going to improve the separation of concerns. No longer are we going to have code that on one line goes to the model and on the next updates the view. Because there's better separation of concerns, we are also going to be able to test our code much more easily. In the last module of this course, I will show you how we can add unit tests to test the code in the view models. When code is more testable, the code maintainability also improves. Once we have a set of unit tests, we can make changes to our code, and through our unit tests, we can ensure that we haven't broken anything. Finally, through the use of MVVM, we will be able to share even more code than we can usually do with Xamarin Forms. The entire view model is fully shareable. Of course, it is not all perfect in the land of MVVM. There are definitely some disadvantages. For starters, when using MVVM instead of a regular code behind-based approach, we will typically need to write more code. I think this is something that'll be obvious once we start building the application in the next module. There is very little support also for MVVM out of the box. What I mean with that is that the tools, so Visual Studio, in general don't have anything built in to support MVVM really. There is definitely more manual work that needs to be done by you, the developer of the application. Because of this, it may sometimes be overkill to use MVVM for very small projects. Although I say that here, I'm saying it more as a warning. Personally, even for smaller Xamarin Forms projects I create, I will always default to using MVVM. Once you get hooked on MVVM, it's pretty difficult to go back. But that is a personal opinion.